we have a slight bit of discussion on instances, right? See,
Yeah,
once again, I'm repeating it because it was happened on last week. So basically, the Oracle server consists of, I mean, two major components. Like, see, this one second. Okay. So here, the Oracle server. Okay, and here Oracle server consists of two major components, right? One is
basically,
that is a physical structure or logical structure. Leave it. Okay, just you see, it's an instance is one component. Okay, instance is one component, and the other one is database. Database. Okay, other one is database. So other one is database. So today we are going to cover completely about this part. Okay, I'm going step by step, so you people can know where I am. Okay, I'm going completely on this instance part, not database part. Database part, I will explain it later. Okay, so you all know what is an instance. Okay, instance consists of memory plus background process, right? Memory in the sense SGA. SGA in the this is one component. Or wait, we'll do. Okay, I will keep memory as mem. It's memory and busy. Okay, and busy. Here database consists of, what are the files database consists of? CRD files. Okay, C means control file, R means read log files, D means data files. These are the mandatory files for database. Okay, without these files, we can't able to make the database up and running. Okay, so CRD files, not only CRD files, other files will be there, but those are additional. Like what are the files? RQ log files. Okay, RQ log files, password files. Okay, and parameter files, network files, so on. Okay, these all things we will discuss later. Today we will discuss about instance. Okay, so basically instance. Okay, basically instances consist of uh, is a combination of memory plus SGA. Sorry, memory plus background process. In memory, what are the things we have in memory? See, so again, okay, again, in instance, we are discussing about memory. That means memory concepts of the instance we are discussing today. Okay, what are the memory components here? As I said, only SGA I said in the last class, but we have like SGA. Okay, that is the PGA. Okay, and one more component is like UGA. Okay, these are the three memory components. Okay, these two are this is one is like additional component, and these two are some kind of mandatory, but this is a private one. Okay, so I'm modifying here what I'm writing. Today, memory. Okay, I'm talking about memory. In memory, we have three kinds. Okay, first one is SGA. SGA stands for System Global Area, right? Second one is PGA, stands for Program Global Area. We call it as Program Global Area. And the third one is UGA, stands for User Global Area. See, these are the three memory components in instance. Okay, so we are today we are completely talking about this memory concepts. Okay, tomorrow we'll go for background process, and day after tomorrow we'll try to cover this database concepts. Okay, this is clear, right? Guru, క్లియర్గా ఉంది కదా? మీకు లాస్ట్ టైం ఇన్స్టెన్స్ అంటే మెమరీ ప్లస్ బ్యాక్గ్రౌండ్ ప్రాసెస్ అని చెప్పాను. ఓకే, మెమరీలో మీకు ఎస్జిఐకి మాత్రమే చెప్పాను, రిమైనింగ్ థింగ్స్ చెప్పలేదు. ఓకే, సో మెమరీలో మనకి ఎస్జీ ఉంటుంది, పీజీ ఉంటుంది, యూజీ ఉంటుంది. ఓకే, సో మనకి ఎస్జీలో ఏముంది? మ్యాండేటరీ మెమరీ కాంపోనెంట్స్ ఏంటి? డేటాబేస్ బఫర్ క్యాచర్, రీడులో బఫర్ క్యాచర్, షేర్డ్ ఫుల్ అండ్ అడిషనల్ కాంబినేషను అండ్ ప్లస్ బ్యాక్గ్రౌండ్ ప్రాసెస్ అని చెప్పాను కదా. ఇవాళ మనం ఏంటంటే ఎస్జిఏలో ఉండే మ్యాండేటరీ కాన్సెప్ట్స్. ఓకే, డేటాబేస్ బఫర్ క్యాచ్ అంటే ఏంటి, రీడ్లాగ్ బఫర్ క్యాచ్ ఏంటంటే, షేర్డ్ పుల్ అంటే ఏంటి, లార్జ్ పుల్ అంటే ఏంటి, స్ట్రీమ్స్ పుల్ అంటే ఏంటి, జావా పుల్ అంటే ఏంటి. ఓకే, ప్లస్ వాటి తాలూకు పర్పస్ ఏంటి. ఆఫ్టర్ దట్ పీజీఏ అంటే ఏంటి, యూజీ అంటే ఏంటి, ఇవి మనం డిస్కస్ చేద్దాం. ఓకేనా? రేపు మనం బ్యాక్గ్రౌండ్ ప్రాసెస్ కోసం చూద్దాం. ఓకే, సో so now we will discuss completely about SGA. SGA stands for System Global Area, as we know, and this is only we called it as, okay, this is also called it as shared memory. Okay, shared memory. This is called as shared memory. Why it is called as shared memory, I will tell you. Okay, let's jump into here. So just give me a second. I'll be back. Okay. Okay. So I'm talking about SGA, right? See, SGA. I'm talking about SGA. Oh, see, this SGA actually consists will be like this. Okay. Here it will be divided into these components: database buffer cache and read log buffer cache and few more.
బ్రో మీ వాయిస్ కొంచెం లోగా ఉంది బ్రో.
Okay, okay. One second. What about now? Is it clear?
యా ఫైన్ బ్రో.
Okay. See, SGA in SGA, what are the components I said? I said uh, shared pool, okay, database buffer cache, redo log buffer cache, okay, buffer cache, and what else? Java pool, right? Uh, Java pool, and what else we have? Uh, large pool, and some uh, streams pool. This is not working again. Okay, streams pool. Okay, so first we will see here shared pool. In shared pool we have two more components. Okay, what is that one? Library cache, LC library cache, and data dictionary cache. Okay, data dictionary cache. So first component we'll see what is shared pool. Okay, in shared pool, what are the things happening, and what is its purpose, and what about this library cache, and what are the operations it is holding, and what is DDDC, and what are the applications it's holding. Okay, these things we'll see now. So I'm going into the PPT. So consider, see, this is the part we are going to discuss today. System global area. This system global area consists of shared pool, okay, database buffer cache, redo log buffer cache, along with additional components, large pool, Java pool, streams pool. Okay, you just consider this part. You just consider this part. Now we are looking into this one, shared pool. In shared pool, we have library cache, data dictionary cache, and other components are there. Server result cache. Okay, we'll see that. One by one, we'll see. So what is an instance is okay. System global area, this one. Uh, this one. Yeah. Shared pool. in this shared pool, okay, most recently executed SQL statements or PL SQL statements or any system database level of parameters or anything will be stored in this area. Okay, will be stored in this shared pool. Okay, because this is because some system users, that means what I am saying, right? See, whenever one user is trying to execute some SQL statement, like for select star from emp table, that is the SQL statement. One user is trying to fetch the details from the database, so he was connected to the database and he was started. If the user is trying to execute this statement for the first time, okay, for the first time, then in this shared pool, okay, it will generate one plan hash value, okay, one hash value to that particular SQL statement, so that what will happen, right? If in for that particular statement, it will be recorded one hash value, one number, it will be recorded. Okay, so in the next time if the user is using the same query and if he tries to access the database and execute that particular statement to fetch the details, then the process will be easier. Okay, so for that purpose, this shared pool will hold all these the most recently executed SQL statements and PL SQL codes. Okay, mostly the users, who are the users we consider as developers. Developers, what will they do? Simply they will write the SQL queries or PL SQL programs. Okay, so this is because some system users and application programs will tend to execute the same SQL statements often. That means the same SQL statement. For suppose, see, here one developer is there, considered as user. What developer is doing? He will write write some SQL queries or PL SQL code to fetch the information from database by running this codes. This codes. Okay. How, for suppose, this developer, what he is doing? This developer is trying to execute this one. Select name. Okay. Select name and status of an sorry status from EMP. EMP is a table. Okay. This is one select query. So user, what this user is doing? This user is trying to fetch the information of name and status from this table, from where? From database level. So he is executing. That means he is passing the statement to the database. So in database, where this will process means it will process in the shared pool. Okay, this will process in the shared pool. Okay, so in shared pool, I have said like two components, like library cache. So shared pool, a library cache, data dictionary cache. This is not in a sequence order. Okay, you can uh, tell in any way. Okay, so library cache and data dictionary cache. What do you mean by library cache means? Okay, this library cache. Anyone came? Guru, are you there? Oh, no, Guru is there. Guru, I think he lost his network. I think. Okay. So Tulsiram, you're following, right? What I'm saying? Okay, great. Uh, so, so this library cache. Okay, what this library cache purpose means? This library cache component. Okay, again, the shared pool includes two major caches. Cache here, cache in this sense, memory. Okay, so library cache. This is a memory where these statements, I said right, these statements are inserting into the database. Okay, so this statement will go to the library cache and it will check for the plan hash. I mean, it will check for the hash value. Okay, as I said earlier, if this statement is running for the first time, okay, then a hash value will be created for this equal statement. Okay, where it will create these all things means in library cache where yeah. Mm-hmm. Tell me. No, wait. Let me remove from the call. Mm. Guru?
Yeah, అది
Okay.
నెట్వర్క్ ప్రాబ్లం అని బ్రో.
Yeah. Okay. So, okay, Guru. See, again, I'm saying, okay, what are the SQL statements? Okay, what are the SQL statements coming from the user, coming from a user as a request to access the database and to fetch the information from the database. Okay, those type of SQLs will be stored inside this shared pool. Okay, that is the first memory component. Okay, which will be accessed whenever a user request come to the database level. So in this in this shared pool, I have said two more shared pool caches are there. One is library cache, and the other is data dictionary cache. Right. So library. See, simply you listen. Okay. Simply you listen and you by heart these things. Okay, what is what, that's all. As of now you have to listen what is shared pool and what is data dictionary cache and what is library cache, as well as what is database buffer cache, what is read log buffer cache. You have to know what is this component and what will this component do. That's enough, okay, for now. Why? Because the workflow process will be there for uh, I will tell you the workflow process, like how one SQL statement comes and process inside the Oracle database. Okay, if one SQL statement comes means into the database, how it will be processed and how the data will be fetched from the database and how it will be passed through user. Okay, as a result, this thing I will tell you in later classes. So before that you have to know what are the components, right? So for that purpose I'm saying this is the component, this is the usage. Okay, and these are the operations happening inside the library. So they said let's continue here itself only. It will be easy for me to give. Okay, so now I'm writing here. uh, SGA, shared system global area. Okay, system global area. In this system global area, we have all the components. The first component we are talking about, that is shared pool. Shared pool. Okay, shared pool which holds the SQL and PL by SQL codes. Let me put it in this way. Okay. This is a memory area where store the SQL and PL by statements. Okay, this is a memory area where it will store the SQL and PL SQL statements which have been triggered by the user. This is the shared pool. And next one. In this shared pool, we have two more cache. Okay, cache means nothing but memory. Nothing but a memory. What is the first cache? Library cache. Second is data dictionary cache. Okay, these are the two caches under shared pool. Okay, as I said, in shared pool, whatever the SQL or PL SQL commands or any application programs are coming into the picture, this shared pool will be hold this information, right? The SQL and PL SQL statement information will be held by shared pool and it will be processed towards to database buffer cache. But in this shared pool, there are two more components like library cache and data dictionary cache. What is library cache and what it contains means is library cache will process this SQL and PL SQL statements. Okay. In this library cache, the CM sequence will be processed and creates a execution plan for that. Okay, creates an execution plan for that SQL and PL SQL statements. Okay, and this operation will be done by a process called optimizer. Optimizer. So this library cache, what it means? This library cache will process this SQL statements. How it will process means Optimizer is one process will be there inside this library cache. What are the SQL and PL SQL statements come inside the database? Then it will check. It will check whether this SQL and PL statements are executing for the first time, or it is executing for the second time or third time or fourth time. Like that, it will check. Okay. If it is executing for the first time, then this optimizer will analyze the SQL statements and it will generate one hash value, and one execution plan will be created by this optimizer based on there are two kind of roles. One is cost based rule and the other one is rule based rule. Okay, based on those two rules, okay, it will create one best execution plan for this SQL or PL SQL statements or application code, anything, whatever it may be, and it will attach in this area. Okay, attach in this area. So whenever if the same user or any other user using the same SQL statement, for example, as I said, this SQL statement is select name status from EMP. If developer is executed this statement for the first time, then in shared pool, in library cache, what it will do, it will generate one hash value for this one, and optimizer will pick that hash value and create one best execution plan. Okay, and it will save it in that library cache. So for the next time, the same user, either the developer or any other application user, come and ran the same statement. Okay, then based upon that hash value and execution plan, it won't do the whole process. Like it will generate one hash value and the execution optimizer will come into picture and access that hash value, and it will create one execution plan. That process it will be skipped. Why? Because already the statements execution plan and hash value is generated. Okay, so directly it will push it to the further, okay, further memory. Okay, so that is what the process happening in the library cache. So write down here. Uh, work workflow. Okay. If the user statement is processed for the first time, then in library cache, now for the first time, then for that SQL or PL SQL code, okay, SQL or PL SQL code, a hash value will be generated in shared pool, and it will and and that hash value is stored into library cache library cache SQL area. Okay, in library cache SQL area will be there. In that it will hold. Okay, so in library cache optimizer will come into picture. Optimizer, sorry, in library cache it will validate whether the code is being running for the first time or it executed earlier. Okay, it will validate whether the code is running up. Okay, this validation is called as parsing. Okay, this validation is called as parsing. Here parsing is of two types. One is hard parse, second one is soft parse. Okay, parsing means nothing but a validation. Okay, simply see whenever a code, okay, whenever a user triggered a request, okay, that request will be validated in this library cache, and it will check whether this particular SQL code or PL SQL code is running for the first time or already it was executed. How this information will be known to the processor means, see, in this library cache already for the first time, then the hash value, I said right, hash value will be generated in the shared pool to that particular SQL state, right? So based on that one, it will come to know whether it is a running for the first time or it is running for the second time or third time. Okay, so if hard parse means nothing but if the statement is running for first time, okay, then that kind of statements are will be hard parsed. Okay, will be hard parsed. What is hard parse? Again, it will create a hash value, and it will and optimizer will create one execution plan based upon that hash value, and it will save it in the library cache. Okay, soft parse is simply quite opposite. Okay, the statement which is in executed for many times. Okay, for many times. This is called hard parse and soft parse. Okay, clear? అర్థమైందా గురు తులసిరామ్?
ఏదో అర్థమైంది లైట్.
యా, అలానే ఉంటుంది. బట్ సి మీకు అదే అంటున్నా, మీకు ప్రాసెస్ జరిగేది ఎలా అని చెప్పినప్పుడు మీకు ఇంకా క్లారిటీగా అర్థం. ఇప్పుడు ఏంటంటే వాట్ ఈజ్ వాట్, లైబ్రరీ క్యాచ్ అంటే ఏంటి, అందులో ఏం జరుగుతుందని మాత్రం తెలుసుకోండి. ఓకే, నేను ఇవన్నీ మళ్ళీ కాంపోనెంట్స్ అన్ని కంబైన్ చేసి మీకు ఒక సెలెక్ట్ స్టేట్మెంట్ ఎలా ప్రాసెస్ అవుతుంది, మన డిఎంఎల్ ఆపరేషన్స్ ఉన్నాయి కదా, అంటే ఇన్సర్ట్, అప్డేట్, డిలీట్, అలాంటి రిక్వెస్ట్ వస్తే ఎలా ప్రాసెస్ అవుతాయి అనేది ఇంకో క్లాస్ ఉంటుంది. ఓకే, అప్పుడు చెప్పినప్పుడు ఏంటంటే మీకు ఈ కాంపోనెంట్స్ అనేవి మీకు తెలియాలి. లైబ్రరీ క్యాచ్ అంటే ఏంటి, ఓకే, డేటా డిక్షనరీ క్యాచ్ ఏంటి, ఓకే, తెలియాలి కాబట్టి చెప్తున్నా. ఓకే, సో ఇప్పుడు ఏంటంటే మీరు సింపుల్గా ఎలా చదువుతారంటే, ఒరాకిల్ సర్వర్ ఆర్కిటెక్చర్లో 2 మేజర్ కాంపోనెంట్స్ ఉంటాయి. ఒకటి డేటాబేస్, ఇంకోటి ఇన్స్టెన్స్. ఇన్స్టెన్స్లో ఏముంటాయి, మెమరీ ప్లస్ బ్యాక్గ్రౌండ్ ప్రాసెస్ ఉంటుంది. ఓకే, మెమరీలో ఎన్ని కైండ్స్ ఉన్నాయంటే 3 కైండ్స్, SGA, PGA, UC. మళ్ళీ SGAలో ఎన్ని కాంపోనెంట్స్ ఉన్నాయి అంటే మేజర్ మ్యాండేటరీ మెమరీ కాంపోనెంట్స్, అడిషనల్ మెమరీ కాంపోనెంట్స్, ప్లస్ ఇన్స్టెన్స్ పార్ట్లో ఇంకొక పార్ట్ ఏంటి, బ్యాక్గ్రౌండ్ ప్రాసెసర్. బ్యాక్గ్రౌండ్ ప్రాసెసర్లో మ్యాండేటరీ ఏంటి, అడిషనల్ ఏంటి. ఓకే, S1 అంటే ఏంటి, P1 అంటే ఏంటి అంటే ఏంటి అంతే, జస్ట్ ఫర్ ఇన్ఫర్మేషన్ నోయింగ్. ఓకే,
ఓకే
అది తెలుస్తుంది. దాని తర్వాత PGA అంటే ఏంటి, UGA అంటే. ఓకే, అదయిన తర్వాత మనకి డేటాబేస్ ఫైల్స్ కోసం సెపరేట్గా ఈచ్ అండ్ ఎవ్రీ ఫైల్ కోసం సెపరేట్ టాపిక్ ఉంటుంది, ల్యాబ్ ప్రాక్టికల్ ఉంటుంది. ఓకే, సో డోంట్ బి గెట్ కన్ఫ్యూజ్, జస్ట్ లెర్న్. సి నౌ ఐఎమ్ టాకింగ్ అబౌట్ SGA. SGAలో షేర్డ్ పూల్ ఉంటుంది. షేర్డ్ పూల్లో యాక్చువల్గా ఏం జరుగుతుంది, మనకు వచ్చే సీక్వల్ PL/SQL స్టేట్మెంట్స్ అనేవి ప్రాసెస్ అనేది ఫస్ట్ షేర్డ్ పూల్ అని జరుగుతుంది. ఆ ప్రాసెస్ అంటే ఏంటి, ఏం జరుగుతుంది ప్రాసెస్ అంటే, అప్పుడు టూ మోర్ కాంపోనెంట్స్ అనేవి హైలైట్ అవుతాయి. ఒకటి లైబ్రరీ క్యాచే, ఇంకోటి డేటా డిక్షనరీ క్యాచే. లైబ్రరీ క్యాచేలో ఆల్ ఎగ్జిక్యూషన్ ప్లాన్స్ విల్ బి స్టోర్డ్. ఓకే, all execution plans will be stored and parsing will be happen. Okay, library cache. And this is the workflow and this is about parsing. కాకపోతే నేను మళ్ళీ చెప్తాను, ఇది మనకి బాగా అర్థం కావాలి, కాకపోతే మీరు చదవాలి. ఓకే, వాట్ ఈజ్ వాట్ అనేది చదవాలి. చూడండి, memory is allocated to library cache whenever a SQL statement is parsed or a program unit is called. Okay, this enables storage of the most recently used SQL and PL/SQL statements. If the library cache is too small, the library cache must purge statement. Okay, ఇక్కడ ఏమంటున్నాడంటే, ఈ లైబ్రరీ క్యాచేలో ఇప్పుడు నేను ఒక సీక్వెల్ స్టేట్మెంట్ అనేది ఎగ్జిక్యూట్ చేస్తే దాని తాలూకా ఎగ్జిక్యూషన్ ప్లాన్ అనేది స్టోర్ అవుతుంది లైబ్రరీ క్యాచ్, రైట్. ఎగ్జిక్యూషన్ ప్లాన్ అనేది ఇక్కడ హోల్డ్ చేస్తుంది, రైట్. అలా రియల్ టైంలోకి వచ్చేసరికి థౌజండ్స్ బిలియన్స్ ఆఫ్ క్వరీస్ అనేవి రన్ అవుతూనే ఉంటాయి కంటిన్యూస్గా 24/7. అలాంటప్పుడు ఈ లైబ్రరీ క్యాచ్ తాలూకా మెమరీ అనేది ఏమవుతుందని అడుగుతున్నారు. ఓకే, సో దానికోసం ఏంటంటే, and creates a execution plans. Okay, so this library cache will be clean up by using LRU algorithm. Okay, LRU means least recently used. That means this library cache size is, for suppose we'll keep it size as 1 GB. Okay, so huge number of user requests are coming inside the database. So this library cache is holding all these user request execution plans, right? So, and the 1 GB is coming to fill up. So at that time, how it will be flushed out, how it will be make some space means it is based upon the LRU algorithm. Based on the LRU algorithm, it will check for the least recently used. For suppose in your library cache we have thousands of SQL statements and execution plans. Okay, in that which one is very rarely used kind of thing, it will identify and it will remove that one. So by removing that one, the space is consumed. Okay, space is released. Okay, so in that way it will release. This is a cyclic process actually. Okay, least recently used. Whenever it is going to fill up the memory, then this based on this algorithm, it will check for the least recently used and it will delete those from the memory. Now, data dictionary cache. What is this data dictionary cache and what it contains? See, data dictionary cache contains, okay, contains all the object, all the database object, database object information. Okay, what are those database object information means? Yeah, like user information, okay, table information. These are all objects, right? See, and what are other objects we have? One second. Hello. Yes. Okay. So this data dictionary cache. Okay. See, it contains all the database object information like user information, user table information, or user privileges, privilege information. Okay, and so on. All the object related information will be stored in this data dictionary. Okay. If the data is not present in the data dictionary cache, okay, I'm saying as a DDC, then it will collect from disk, and place it into this memory. Place it into this memory. If this information, if any information, for suppose one ABC user's information is not available in this data dictionary memory, then what it will do, it will simply go to the disk and it will collect the information. Why? Because all the information will be stored inside the disk permanently, right? So that from that disk it will go and it will collect and placed into this memory. So this is the purpose of data dictionary. Okay, this is the first phase. This is the first phase in SGA. The second phase is database buffer cache. Now we'll see into database buffer cache. In SGA, Shared pool is completed. Now we look at database buffer cache. The second component is database buffer cache. Okay. This is very simple. This database buffer cache is DBBC library cache LC data dictionary cache DBC and this database buffer cache DBBC. Okay. Is the memory area where the actual data processing will take place. Okay. This is the memory area where the actual data processing will take place. Okay. In this particular database buffer cache, the actual what are the data is going to process, those things will be processed here. Okay. That means this SQL statement, okay, this from EMP table, it is fetching name and status. Okay. That is directly, if it is in database buffer cache, it will fetch from there and it will give it to the user. If instead of select query, if any DML operations is performed, like insert, update, or delete, okay, those kind of operations, okay, will be happen in this database buffer cache. Okay, that is database buffer cache. Here we have, see, data dictionary cache, user account information, user privilege, data file names, table space, tables information. Okay, all this information will be stored in data dictionary cache. And which one? Database buffer cache. In this database buffer cache, see, this is the database buffer cache is the largest memory area in SGA. In SGA, this is the largest memory area. Why? Because the actual process will be going to happen in this buffer cache, in this memory. Okay. Memory area stores the copies of data blocks that are read from the database disks called data files. I said right, all the data will be stored permanently in the disk level. Okay. Those disk level, in the disk level, we have data files. Data files means data blocks. Okay. Those blocks will be processed here in this buffer cache. Okay. Based upon these two algorithms. Least recently used algorithm, most recently used algorithm. Okay, based on these two algorithms, this database buffer cache will process. Okay, so database blocks are kept in database buffer cache according to the least recently used algorithm and are aged out of memory. Buffer cache block is not used in order to provide space. As I said in the library cache, okay, this least recently used, least recently used means it will check. It was not used for many times. Those kind of what we call, those kind of blocks will be removed from the memory in order to make some space. Okay. See, aged out of memory, if a buffer cache block is not used in order to provide space for the insertion of newly needed database blocks, for newly needed database blocks, and to make some space, okay, these least recently used blocks will be removed. Okay. In this buffer cache, we have three buffer states. One is unused, clean, dirty. Okay. And two more access modes are there, like pinned and free. What we'll see into this. Okay. What is unused? Unused means a buffer is available for use. Okay. That means that means in this buffer cache, this is a database buffer cache. Okay. Here one block is there. Okay. One block is there. The user requested for the update statement. update statement. Then here this is an unused block, right? That means it is ready to use. Then this statement will go into here and it will process here. That is the state of unused. Okay. Clean. Clean means already this is processing, right? After completion of this process, this block will be cleaned. This block will be cleaned and it will go to the unused state. That is clean. Okay. A buffer that was used earlier, the data has been written to disk. When it will be cleaned means once the process is completed and once it committed to the disk, that means when it return the data permanently into the disk, then it will be cleared. Okay, then it will be cleared. Then when it is being processed, that means when it is updation process is currently doing, okay, currently this is in use. This kind of block is called the T block. Okay, the T block. The T block means in buffer cache. That T block means that block is currently being used, currently being writing. That kind of block is called the T block. Okay, clear means that the T block is ready to is committed and ready to and permanently saved into the data file. Okay, this block came here. Okay, this block data. Then it will be free. Then it will be released. It will be cleared and it will be into unused state. That means ready to use. Okay, that is about unused, clean, and dirty. And each buffer has one or two access modes. One is pinned and the other one is free. If any of the if any of the data is pinned, that means it will not come into the least recently used algorithm. Okay, why? Because if it is pinned, it is continuously being used in the memory. That is called pinned. Free means unpinned. For suppose I have pinned this one. Okay. For suppose I have pinned one block permanently in the memory to do some select statements. To do some select statements. So until unless if we unpin this one, okay, this will be settled here. Okay, this will be settled here and it will be processed here itself. Okay, it won't be released. That is the pin. And if you see the below, one more thing. How can I show you that one? Uh, yeah, catchy hit and catchy miss. These are the two more terminologies. We'll use it in database buffer cache. Okay, catchy hit means while the user is trying to fetch data from the database, and if that data information is present inside the database buffer cache, then that is catchy hit. If the data block is not present inside the database buffer cache, then that will be catchy miss. That means, for suppose, see, this is the database buffer cache. EP PC. Okay, for suppose uh, update statement, select statement, insert statement. Okay, so here this is the our databases files, data files will be there. Okay, here our data files will be there. So catch a hit and catch a miss means, okay, for suppose one block is updating. Okay, one block is updating. Okay, so the data will be pulled from disk level and it will keep it here. It will keep it here. At the same time, okay, at the same time, at the same time, if user is trying to fetch the same data, okay, for suppose one employee's data here it is updating from 1000 to from 5000, okay. At the same time, one user is fetching the information from that table, okay, from that user table and employee table, okay. If the information is present inside the database buffer cache when the user is trying to fetch the information, then that is a cache hit. If this 1000 value is not there and it was updated already, okay, 5000 is there, the 1000 is not there here, then in this buffer cache this value is not there, so this is a cache miss, okay. This is about data database cache hit and database, sorry, memory cache hit and memory cache miss, okay. Clear, right, Guru?
Yeah, bro.
Yeah. So that is what cache hit and cache miss. As I said, it was run on the two algorithms, right? Least recently used algorithm and most recently used algorithm. This is what. See, most recently, least recently. If this jet, sorry, see, these are the algorithms most recently used and least recently used. See here diagram. For suppose the select star from X is the first select statement which come into this memory. Then it will be placed here. If another statement comes means, okay, this X will move to the second block. If another statement comes means that X will be moved to the third place and the first place will come to second place. That means X is executed first. Okay, it is here. Then again select star from Y statement came. So what will happen? This X will move to this place and this Y will be here. And the third case, third statement also came into picture. Then what will happen? This X will move from here to here and Y will come from first place to second place. And the latest statement will come to last place, right? In this way, it will move. Why? Because see, this X is used for only one time. So that's why it is moving. If the if the X again we hit it, then it will be coming to this place. Then it won't be coming to least recently used. So what are the statements coming to this most recently used area? Those will be vanished out of the memory. Okay, that is the meaning of most recently used algorithm and least recently used algorithm.
Yeah.
This is the workflow, how database buffer caches. See, process flow. When an Oracle user process needs a data row, first it searches from the data in the database buffer cache. See, user process here means user. Okay, if user is trying to access the data from the database, then first it will go and search in the database buffer cache. Okay, if the data is found in the database buffer cache, okay, that type of hit is called cache hit. If the data which is a user is trying to fetch is not present in the database buffer cache, then it will be a cache miss. Okay, because memory can be searched from more quickly than hard disk can be accessed. If the data row is already in the cache, see, a cache hit. The process reads the data from memory and it will give it back to the user. Otherwise, a cache miss occurs and data must be read from the hard disk into and it will place over to the buffer cache and from buffer cache it will give it to the user. This is the process. Okay. So this is enough for database buffer cache. You simply, guys, this will work on two algorithms. One is most recently used. Most recently used. Second one least recently used. Okay, most recently. And in this database buffer cache, we have three types of process. Three types of process, right? What I said, used, unused, and sorry, used. Oh, sorry, recording messed up. Okay, see, this is based on two algorithms. It will work, and in database cache we have three types of states. Again, first one is unused state. Okay, unused state, that means this is ready to use. This is empty and ready to use. Okay, unused state data block means this block is ready to use. This block is ready to use. Yeah, yeah. Thank you. And the second one is unused completed. Okay. Uh, clean, clean state or clear state. Clear state. In this clear state, the block that which is complete its process and save to disk permanently. Save to disk permanently, and it will be removed from memory. Okay, see, this is what that the clear state means. Block, okay, the block which is processing, it's completing its process, and it is saved into the disk for permanently, saved into disk permanently, and it will be removed from the memory. So those type of blocks will be and it will be removed, not removed, it will be empty, and it will be empty. Will be empty. Why? Because once the data in the data block was written into the disk permanently, then that data block will be empty. Okay, that is called clean state. Clean or not clean. And third one is dirty block. Okay, dirty state. In this state, the data blocks are in this state where the data blocks are currently in use or in use or process. Okay, in this dirty blocks. Okay, as I said here, This is a block. So here update statement is coming here. So from 1000 it is updating to 5000. So this block is currently been updating. That means it's currently being used. This kind of blocks is called dirty blocks. Okay. This kind of blocks is called dirty blocks. Okay. Dirty blocks. And in this cache hit and cache miss. Or two types will be there, cache hit and cache miss. What are these? Cache hit. Cache hit means data available in the database buffer cache then that is okay. I'll keep it. Whenever a user tries to fetch data from database, then if that particular okay data is present in memory. Here memory means DBBC. Okay. Why? Because we are talking about DBBC. Then it is called as cache hit. Okay. Then it is called as cache hit. Cache miss. Cache means the same process. If the data is not present in buffer cache, okay, we'll keep it here present in instead of memory. This is buffer cache. This is clear. Okay. If the data is not present in buffer cache, this type then it is called cache miss. Okay. It's called cache miss. Okay. Well, now you're clear. What is cache hit and what is cache miss, right? Okay. Now the
Yeah.
third one. Now the third one. We're going redo log buffer cache. Redo log
Buffer.
buffer cache.
Shit.
RLPC. Here in this redo log buffer cache, the main purpose of RLBC is to store all the changes that are happening in database buffer cache. Okay. For recovery purpose. See. Now we are talking about the other one. third most important component, that is that is okay. One is shared pool, and the other one is DBBC, and now the read log buffer cache. So this DBBC is the biggest memory component in SGA, right? In SGA, this is the DBB. Why? Because here the actual data processing will be happen. Okay. So as I said, here one block is updating with this one 1000. Okay. Go to heralds. Okay, here something is updating. Okay. So as per the data access language, whatever the things you are updating, it won't will be saved immediately into your disk permanently. Why? Because we have to do commit. Until unless if you didn't give commit, then the data will be not saved permanently. That is clear, right? So here you are giving 1000 and you have updated the value. Okay, here the value is 1000. So from 1000 you have updated to information is there, right? This information will be come and stored in this develop buffer cache. Why it is going to store these updations? I mean the modifications which are happening for the data in this database buffer cache means for recovery purpose. If yes, if the data is updating here and was not saved permanent, commit was not happen. If all of a sudden that particular table, I mean this particular data is lost, that particular data is lost. So for other users who are accessing this data block, they will get 1000 instead of 5000, 1000. Okay, and okay, if I will keep it in this way. Okay, so you you have a bank account. Okay, you have a bank account. Today in you have around 10,000. So today you came and deposited some 20,000. That means overall how much you should have 30,000, right? You have 30,000. Hmm? 30,000 should be updated. Okay, while uh, while the bank okay worker is trying to update here, at that time the system was crashed and this was not saved. Okay, he was updated like 20,000, but he didn't click the save button. Okay, at that time period only the system is crashed. So now if you go to the ATM or if you open your mobile app and if you check what is your current balance, okay, in that case it will show only 10,000. Why? Because this update is not saved permanently. Okay, so then what will happen? Do you have any records that you have deposited 20,000 like this? Right, then what will happen? You will lose this information. 20,000 information will be lost. There is no record. Why? Because you didn't save anything. So to overcome this kind of situations, okay, Oracle, in a brilliant way, what it would do, what are the changes happening in this database buffer cache? Those changes will be replicated. Okay, those changes will be saved in this redo log buffer cache for recovery purpose. If this transaction is gone here without saving, then by recovering the particular block, we can get back this value. For that purpose, this redo log buffer cache is used. Okay, clear it. Main purpose of redo log buffer cache is to store all the changes that are happening in DBPC for with what purpose recovery purpose. For what purpose recovery. Okay, this is redo log buffer and additional components. What are the additional components? Java tools. Okay, and large tool and what is the other one?
Stream.
Streams full.
Full.
Okay, so Java full. What is the main purpose of Java full means? From client side, okay, that means out of the database, the client process will be there. Those or any other Apple OS applications or some other applications, right? Okay, to handle those type of applications request, there is a dedicated memory called Java pool. All the Java related, okay, process will be handled here. Handled here. This is Java pool. Okay, large pool. Large pool is used for our backups and recoveries. Okay, we have a concept called RMAN. In backups, we have a concept called RMAN. RMAN means recovery manager. Okay, recovery manager is a utility tool to manage and to perform our backups and restore and recovery options. This is completely related to our backups. Okay, uh, this is completely related to handle our backup process. Okay, principle. Principle is also similar. This is also a database thing only. Okay, here the memory is used for, okay, media. One second, let me see. Database buffer cache, database redo log buffer cache, redo log buffer cache. Okay, large pool. See here, backup disk. Arman uses this only if backup disk IO, and this is for backup related. Java full. Okay, this is for Java installed and used for Oracle Java virtual machines to pass the Java commands. This is for Java. And streams pool. Streams pool is additional, like okay, Oracle streams futures. Okay, used for storing and control the Oracle related programs. Related third party. Okay, this memory is used. And I forgot to tell here in redo log we have three states: unused, current. What are the three states? Types of redo logs. Yeah, unused, current, active, inactive. These are the four states. Okay, unused means in the same way in the database buffer cache I have said, right. Okay, unused. Unused means files which are not used at any point of time. In redo log buffer cache, unused state means that particular log file is not used, not at use. That means ready to use. Current means which is currently been writing, which is currently been writing. Active means okay, that is being written, and uh, it is ready to store the data into the disk level. That is active. Inactive means whenever the data is written permanently into the disk, then that file will be inactive and it will again go to unused state. Okay, see here. Okay, I'm taking the redo log buffer cache RL PC. In this redo log buffer cache, we have online log files. We have online log files. Okay, what are the information it is taking from the database buffer cache and it is processing here and it will be stored into some files, right? That is the log files. So this log files is see, this is empty. These log files are not in use. This means this is in unused state. If it is being writing currently, then this is the current. Okay, and if this is got filled and the log switch occur and it will go to the next log file, then it will start writing. When this log file, when the second log file starts writing, then this will be in active state. That means these files should be written to disk permanently. Okay, these files will be written into disk permanently. Then this will be filling up. In the meantime, this will be releasing. These all things will be written into here and this will be releasing. Okay, so from this active state all the files will be saved permanently and this will be become inactive and ready to use. Inactive means it will be empty. That means empty means it will be ready to use, right? Then it will be go to unused state. I'll show you in the practical session, then it will come more clear. Okay, so
Yeah.
here we have four stages. Okay, what are those four stages? First one is unused state, yes, which means that which means this particular log file. See, all redo log files will be written to online redo log files. Okay, particular log file is empty and ready for use. Ready for use. This is unused. Second one is active or current. It will be in a sequence order. Current. Okay. Current means it is in writing at present. Okay. Third, active. Active means the log file is complete writing and it is ready to save the data into disk permanently for recovery purpose. That is the main concept, right? Read log buffer cache. These records, what are the records saving in this read log buffer cache? The main purpose is for recovery purpose. Fourth one, inactive. Inactive means see data is been written into a disk and disk and the log file will be empty. Okay. And from active state it will again go to unused state. This is a cyclic process. First unused state, then current means actively it is writing into that log file. Okay, active current means see unused. That means that is not used. Okay, active means it is currently writing. This is the active state. Sorry, current state. So once this got filled up, this is in active state. Why active state means this data should be saved permanently, and once it was saved permanently, this data should be erased from here. So this active state, this will be ready to write into the disk permanently for recovery purpose. Once everything is written into the disk, this will be cleared off. That means it will be inactive, then it will be cleared off, and it will go to again unused state. Okay, this is about the memory components of our database. Okay, the background process. And before that, I have to tell you about PGA and UGA, right? Tomorrow I will cover that one. Okay, tomorrow I'll cover that one and I'll start background process. This is a small concept. No need to worry. Okay.
Yeah.